Thank you everyone for being here. So just a quick introduction about 4ID. So we're just on 20 years of being in operation. We're a business located in North Wyong with a team of 25 people, and we're always looking for quality people to join our team. Most members of our team have joined the team from the Central Coast, so they've been locals to the area, and they have joined our team without necessarily coming from a technical or printing background. So the team that we have is from a very varied skill set outside what you would normally expect for a business that's involved in printing. And a big part of that is because printing is just a very small part of what we do. We're more about the technology and the smarts that we put into our labels. We're internationally recognised amongst our peers and those that we deal with around the quality and the products that we produce, both in the timeliness of our products production, but more importantly for us, the quality. Because for us, quality is the key. Anyone can make labels, but with what we do, the labels are a lot smarter than a normal label, and quality does make a big difference in what we're doing. So I'll just move over here for a moment. So for those people who aren't familiar with RFID, RFID is basically any technology that uses radio frequency to identify an item. So the aspects of RFID that you'd use in daily life would be things such as key fobs, the functionality of your tap and go in your bank cards, the toll transponders, library books, even Bluetooth is a form of RFID, in that, as well as being a communication protocol, it also facilitates the identification of different devices. So it knows when your phone has got into your car or when you've opened your AirPods and things like that. So a lot of people use RFID in their daily life and not be aware that they're actually using it. So there's two main subtypes of RFID, if you like. So there's passive and active RFID. What we specialize in is passive RFID. So there's no battery in it. So it's required to be in an RF field or a space, and that's how it gets its energy to respond. So think of it as being in a conversation. You need to be in that area with someone to be able to engage in that conversation. It's exactly the same with passive RFID. Active RFID generally has a battery in it. The disadvantage of active RFID is it then comes with a finite life because the battery is only going to last for so long. With passive, it'll last for as long as the tag does. Main applications for the passive RFID are in logistics, retail, all of those sort of things, because it's a very cost-effective option. When you start putting batteries in things and having to have them in special cases, it becomes a lot more expensive. So they're mainly used for higher value items or items where extreme durability is required, and people accept that as that trade-off, they are going to have to change those batteries. So the exciting thing that I'm here to talk about today is passive sensor-enabled RFID. So we're currently the only company in the world who is converting this particular IC from a company in France. So they make a suite of ICs. So that's what it looks like. So that's about a 2 mil by 2 mil square. That's what it looks like if you really zoom into it. And the big advantage of these ICs over traditional UHF inlays is, as a default, they can report on temperature. As an added bonus throughout their suite of products, they can do temperature and strain, temperature and humidity, temperature and light, or you can add external sensors to the IC, and your options there as to what you can detect are then limitless. So whether it be vibration, magnetic effect, orientation, all of those can be identified through external sensors connected to that IC. So some of the use applications for these products in the building and construction industry, as an example, are in concrete curing, understanding the state of the concrete without just sticking your finger in it or looking at it and say, yep, it's cured. You can scientifically know that, yes, it's at this temperature, there's still this much humidity within there, so it's at this stage of the process. You can use it for monitoring structural health of buildings and things like bridges, so you can see, as an example, in the event of an earthquake, you can detect the strain that's gone through a building through that event. And you can also use it for leak detection. So whether you have it on the outside of pipes to detect leaks in concealed spaces, or even putting it behind the ceiling areas within wet areas like showers and things like that, you can use this sensor-enabled RFID to determine exactly where the leak is and the source of the water without having to randomly pull off tiles to then hope that you've started in the right spot. Ooh, sorry. A big area of interest for it at the moment is in the food and beverage space, specifically in cold chain logistics. So there's a lot of interest in this product at the moment as grocery stores and food distributors look to engage pardon me, with traditional RFID for a very small additional cost. They now have the ability where they can monitor the temperature that strawberries have been at during transit, as an example. If those strawberries have been frozen or if they've got too hot, they're not going to have a very long shelf life. So when, for example, the local Coles receives those, they can tell that it's had these temperature incursions, and so they can at that point reject that product. So it's about quality for the end customer, but it's also about taking it back up the supply chain for accountability, but also to understand what's happened in those instances and prevent them from happening again to reduce food waste. So if you've got the biggest shelf life and you've looked after it on its journey, that's the best process you can go through for trying to eliminate waste in the food space. By monitoring the temperature and humidity, you can optimize the watering systems in greenhouses, in hydroponic environments and things like that. Or you can also use light detection, so you know that, okay, the bottom of that plant isn't getting any light, and so we need to move these plants to a different area, or we need to adjust our lighting and things like that. Seed and grain is another area where it's used, where they want to be able to detect if there's moisture accumulating in a bag that's full of a particular seed. Obviously that can lead to germination and things like that. So this gives them the ability to generate those alerts through their full system to understand what those humidity levels are like and what the temperature levels are like as well. More importantly, and most importantly for some, it's used for monitoring the condition that wine is in, both in a winery, but also in a home cellar environment. So there's some applications that we're looking at where we're looking to identify the amount of light that a cell is exposed to during the day, the temperature and the humidity, but also being able to detect whether or not that bottle is still there by using a strain functionality. Health and pharmaceuticals, it can be used, again, a similar aspect to the food, where we're using it to monitor the temperature of goods in transport and goods in storage. There's a lot of different applications for it around patient care. So it can be used to monitor patient movement. If a patient is moving, how frequently they're moving, how long they spend in bed or out of bed. So especially important if you've got people who are in rehab and things like that, so they need to be up and moving. If they're not moving for a period, like as in getting out of the bed, for a period of a few hours, it can issue alerts to tell the nurses or the care providers to go and encourage this person to take a walk or to do this rehab that they need to do. It can also be used to detect moisture. So in the event that there's moisture within the mattress and those sorts of things, that can be identified to improve patient care and patient comfort. And then finally, it can be used in the transport of specimens. So specimens are very susceptible to humidity and temperature, whether they be blood, biological samples, things like that. They're very susceptible. So again, it gives you the ability to wirelessly be able to identify the temperature in that transport. In industry, predictive maintenance, electrical cabinets and gas monitoring. The most exciting space that we see there is the predictive maintenance, being able to see elevations in temperature, elevations or sudden drops in strain and pressure as an indicator of things are either starting to fail or things have drastically failed. And you can have those alerts rather than having to send people into hazardous environments as well. You can have those alerts remotely by effectively a little sticker that you've put on the side of something. And that's what I have to talk about sensors. Anyone who's interested in sensors, we have an array of displays down in the Tasman room, so you can come by and have a look at them in practicality. But if you have any questions, feel free to let me know. Thank you very much.